Okay friends, welcome to part 2 of our video tutorial on assignment 9. In this tutorial we will start talking about the fourth important step under the scientific paradigm called data and methodology. Again, to explain the link between data and methodology and the theory section, I would like to say this. Theory means you come up with specific statements that outline relationships, either positive or negative or general causal relationships among the variables that seem to be related to your problem statement, to your problem area. Now, in our case, the ultimate problem, the ultimate variable that we are trying to explore is concussions, right? What leads to concussions? So you may have certain theories, like in my previous presentation, I came up with some ideas that, something that will influence frequency or risk of concussion is which position a player is playing. Is it offensive position or defensive position? Also the type of practice and so forth. So all those things, they are your theories, those specific ideas as to which variables or factors influence concussion. So once you come up with those ideas, you need to use data, you need to collect data, and then use some kind of methodology to expose your ideas, to put your ideas to test, okay? And that's what we will do in this, or start doing in this part of our video tutorial on assignment 9. We'll talk about data that is given to you, and we'll talk about one method to test some of those ideas that you came up with in the theory part. We'll talk about using queries to explore some of those ideas. By the way, this data is given to you. I uploaded this skeleton file, so you don't have to worry about entering it. And once again, it illustrates that point that sometimes as a data scientist you just have to go with whatever data is already available, because sometimes it's either impossible or prohibitively expensive to collect data in relation to a particular problem. Like in your problem about concussion analysis, I mean, you cannot afford to start observing those concussions for the next 2 years because this problem is very pressing. It needs to be addressed now. So you have to use whatever archival data about concussions is already available. So we can imagine that I'm giving you this archival data. So the first table that I would like to discuss is data, the table called players. Now here you have, as the name suggests, you have information about players, and you have a lot of them. So you have 300 players listed here. I think like most of those attributes within this table or columns, they're self-explanatory. First of all, you have player number, so it's some kind of code or an ID that uniquely identifies each player in the conference, each college player in the conference. Then you have player last name, first name. Then you have position. Now there are many positions here, and I suggest you read about those positions, in Wikipedia. Because once you understand those positions better, and I'm sure a lot of people, they do understand those positions without any explanations because they're football fans and they've been watching it for a long time. But it's something that will help you to understand the problem. In other words, it will help you to understand whether the position has anything to do with concussions. And I'm sure it does, because there are certain dangerous positions within a team, meaning people in those positions, they get attacked all the time. And there are certain relatively safe positions where the chance of injury is not that high. So first of all, for example, you have quarterback, you have center, you have wide receiver, and so forth. To be honest, myself, I'm not familiar with all of those positions because I'm not that knowledgeable in football. In fact, I would say my knowledge is very superficial. And then you have team information, which team a particular player belongs to, and then you have side, meaning offensive or defensive player. So this is the information that you have about players. Now, the second table I would like to talk about is teams. So here you have information about 8 teams. So we have 8 names. Now, actually 2 important attributes of each team are home field and practice. Now, home field basically means what type of grass, what type of coating their home field has. So some teams, they have natural grass, meaning it's just normal natural grass, and they grow it on their field and they use it for practice. Now, other teams, they use something called turf. Now, turf means like artificial synthetic grass, or artificial synthetic field covering. Now, I have an opinion on that myself. But I think my opinion is supported by most people. I think natural grass is a bit safer. I mean, it's a bit less slippery, and also, as somebody told me, there is less. Well, there is better amortization. For example, if you fall on natural grass, you know it's not going to hit you that hard. Now, turf, that synthetic coating of fields, first of all, it may be a bit slippery compared to natural grass. Number two, it doesn't have this natural ground as a cushion. You know, some people say that, well, there's like a hard concrete foundation behind, you know, underneath this covering, so so it doesn't absorb impact, doesn't absorb, doesn't prevent injuries to the same extent as grass does, natural coating does. So this can be another factor to explore, whether type of field, you know, is related to concussions. And then the third column, the third attribute, it's practice type. This has to do with man-to-man contact. So, for example, high means that this particular team prefers high man-to-man contact during practice, meaning there's a lot of interaction between players. Medium means medium contact. Low means very low contact. You know, let's say the emphasis is on general physical development. Let's say weightlifting, running, as opposed to actual practice. You know, where people wrestle and hit each other. So this is the information you have about teams. Now here you have information about incidents. I'll close the teams table. So basically here you have information about injuries, about concussions for the last 2 years. So every time a concussion happens, in the conference, during the game, or during practice. No, I think this is data about actual games. So. Well, anyways, let's just assume that whenever a concussion happens in the conference, whenever any football player gets a concussion, this data is recorded. So here we have a code for concussion. It doesn't, this is not like, it doesn't mean like, the concussion occurred 8 times. It just means that this is report number 1, this is report number 2 about the player injury. So here we have the player involved. This data comes from the player table. Here we have information about games missed as a result of that incident. So this particular player missed 1 game. On which field, on what type of field the incident happened, turf or natural grass, and in what year. And we have a data for a total of, for 2 years. So we have a total of 380 incident reports. So this is the data that you're given now. Again, this data is given to you. You cannot go back and include other variables. You may, but that may be a bit expensive and difficult. So you have to go with whatever data you have currently. So this is your data. Now, scientists usually, when they get data, they don't start like testing their hypothesis immediately. First of all, they explore this data. They try to summarize it. They try to subject it to basic, stats, like basic statistical tests, like just find averages, to look at standard deviation, variance, range, and all those things, to get to know the data better, to get to know it better, and also to see whether some preliminary ideas come into their head, to see whether some patterns emerge. Okay, now. In science, sometimes this practice is looked down upon. They call it data mining, and to most people, data mining is something that is good, meaning data mining helps you find patterns. But scientists, some hardcore scientists, they prefer to stay away from data mining. Now, what they're saying that I remember there was a sign on the door of one of my professors who was a statistician, and the sign said something like this: "If you torture data sufficiently, it will confess almost everything." Or almost anything. So if you torture data sufficiently, it will confess almost anything, which means that you can find anything you want. I mean, if you have some primary belief, you can just mine data back and forth, and you will see all kinds of patterns. Now, of course, some of those patterns, they will not be like true patterns, meaning the true knowledge, but some kind of random chance occurrence. Okay, so that's why scientists say don't explore data, just come up with your hypotheses, and then test them. Don't explore, don't find your hypothesis from data. But of course, there is a philosophical counter-argument to that. Like, there's a German philosopher called Immanuel Kant, and he wrote this book called Critique of Pure Reason, where he argues that, human brain is simply not powerful enough to come up with knowledge. In other words, we always need to have exposure to real world, meaning to real data, to come up with ideas. By the way, the same philosophical principle is used in system analysis and design, In prototyping, basically prototyping means that you don't expect users to come up with ideas about features of an information system. First of all you let users see a prototype, meaning like some kind of real world model, and based on that model they can come up with ideas, and they can give you a better insight as to what kind of features they require from an information system. So it's a very powerful principle, and I think the reality is that most scientists, they do that. I mean, they explore data, they try to see patterns, and then they go back to this theory section and then revise it based on what they actually see or don't see in the data. So I think that's something that is looked down upon, but this is something that happens and exists, meaning exploring your data. So for example, what you can do, using queries, you can get information on players that have more than 2 games missed. So this is one of the queries. So you look at them and maybe you'll ask yourself, well, do I see any pattern there? I mean, is there something particular about those players that have more than 2 games missed as a result of concussion? Now the mechanics of that query, they're right here. So basically from the player table you're displaying player number, last name, and then from the incidents table you're displaying year when the incident happened, and then games missed in descending order from the incidents table, and you have criteria. It has to be greater than 2, and also you're displaying which team this player comes from. Now of course you need to specify the relationships among tables. You need to specify the cardinality. If you forgot about doing that, then you go to database tools, relationships, and then you just display all 3 tables, and here you specify those relationships simply by dragging and dropping those tables, right? So for example, team will be linked here, player table will be linked to the teams table through the team primary key. Then player number key will be used to link the player table to the incidents table. So you just drag and drop those things, those variables, to specify the relationship. So it's a one-to-many relationship here. Well, anyways, let's go back to the significant games missed query. I'll close this one. So yeah, so this is the query. I told you the mechanics and sorry. So when you launch this query, you will get information about players who have more than 2 games missed, and in what year that happened, and which team they represent. You may also start doing some aggregations like summary by side. So you see we have offensive and defensive player. So the way this query works, basically we want to see injuries for offensive and defensive players. So this is how the query will work. First of all, from the player table, you retrieve the side field, and then you group by it. In other words, there will be grouping by offensive and defensive side. And here you have a count query. So this is just label. So you count injury number. Now you just count their appearances in the incidents table, right? You don't like add them, right? And here you do sum. From the incidents table, you just do sum of all games missed. So this is the mechanics of this query, and when you launch it, you see that offensive players, we're kind of jumping a little bit to the discussions of results section, because our methodology that we selected this query, so we're trying to test some of the hypotheses that we came up with during the theoretical analysis using queries. So that's why we already have those results, and we're discussing them a little bit. So what I see here is that offensive players, indeed, they get more injuries and they tend to miss more games. Something that seems to support this hypothesis is that the type of player, the type of position in a team influences the likelihood of obtaining a concussion. Now, this question can be explored in more detail by looking at the frequency by position. So this is how this query looks like. So you're from the player table, you're displaying position, and you're grouping by this variable, and once again you're counting incidents for each of the player position in the incidents table, and then you are sorting it in descending order. If you launch this query, you'll see something like this. So wide receiver is the player that seems to receive the most injuries. If you think about it from the perspective of football game, how it works, it kind of makes sense because wide receiver is the one who tries to catch the ball and score with it. So he is the most frequent target for defensive players. In other words, everybody's trying to take him down so that he won't catch the ball. And then you have other positions that have less injuries, and you can provide like theoretical interpretation based on your knowledge of the football game, like why quarterbacks receive less injuries than wide receivers, and why centers they have the less number of injuries, why they're so why their chances of receiving a concussion are so low. So you may want to explore that. Frequency by team, another query. So here I'll close. So to eliminate confusion, I'll just close those previous queries. So basically, you're displaying number of injuries and number of games missed per team. This is the mechanics of the query. So you just group by team name. Once again, you're counting number of injuries, and then you're summing up all the games missed. Now there's a difference. It's a count versus sum. Count means you're just counting the occurrences, so you're not really summing those incident coefficients or anything like that. You just count the number of incidents. But sum means, in the incidents table, you're actually summing the games missed. Okay, so it's a totals query. So this is how this query looks like. So here you see that you're just counting injury numbers, injury codes. You're not summing them or anything like that. So if you launch this query, you'll see injuries by teams. Again, one team stands out, the team with the name Snakes. It has the highest number of injuries and the highest number of games missed. So, looking at those results, you may want to do something with this team. Maybe you can pay a close attention to this team. What exactly they're doing, what is their practice regimen. In other words, you want to find out why they have the highest count of injuries and the highest number of games missed by players as a result of those injuries. On the positive side, it looks like cruisers have the least number of injuries and the least number of days missed, or one of the lowest numbers for games missed. So you may want to explore this team as well to see what are those things that they're doing right to prevent concussions. Also here in this table you have summary. In this query you have summary by year. So basically what you're doing, you're displaying year, and then this is your grouping variable, and then once again you're counting number of injuries and you're summing the days missed. If you launch this query, you see that it looks like the number of concussions and the number of days missed are growing. In year one it was only 140, it went up to 168. I'm talking about number of concussions. And the same thing happened with the number of games missed. It went from 177 to 235. So again, you may want to ask why. Why is that the number of concussions and the number of games missed is growing? What was the difference between year one and year two? So maybe in year two the safety rules became less stringent. I don't know what it is, but this is something that needs to be explored. So you have this data, and then you need to drill down. You need to dig deeper and see why you have this data. Okay, and then at the end you have a summary data table. Basically what you're trying to do, you're trying to retrieve all information that seems to be relevant to concussions, to injuries, and then later on you will analyze this information in detail using Excel. So that will be a different methodology that we employ for analysis. So basically you retrieve all information about injuries. You have injury number, player number, who received that injury, year, when it happened, the position of the player, the side he was playing on, offensive and defensive, the team, the type of home field, the type of practice that he was exposed to as a result of belonging to a particular game, and then game field. Yeah, so you have information about both home field and game field. So all this information will be later on exported to Excel, and you will use pivot tables in Excel to analyze the problem of concussions even further. But this concludes part 2 of our video presentation on assignment 9. Thank you for listening.